Yeah, there's one on my desk there.
Hey, Ralph.
Ralph!
Hey, Ralph.
Thanks.
Oh, yeah, I got that grandparents.
Have a good day, Ralph. Maybe one of the kids said.
All right, number one. We're supposed to graph this function g of x. When we have, I'm talking guys, when we have a rational function like this one, where the numerator is just a whole number, okay, then the denominator, like in all of these rationals, the denominator tells us the what? The vertical asymptote, which also tells us the domain, right? So what makes that 0? So therefore my domain is x cannot equal 1, right? All real numbers except 1 is the domain. So we've just been writing it like that, okay? For the horizontal asymptote, it's y equals whatever this number is. So that would be 4. The range then is y is all real numbers except 4. Okay? Questions on that? If, again, and that's when it's just a whole number in the numerator. Okay? When we go over number 3, it's a little different. For the horizontal asymptote, the vertical is the same. The horizontal is going to be a little different because we have a variable in the numerator. Oh, the same with 2 and 3, I guess. Okay, any questions on how I got those two answers? The graph part is just doing your calculator, but, okay, in order to get full credit on your graph, make sure you draw your graph correctly. Okay, if we say the vertical asymptote's 1, then that's this dashed line. You can put a little 1 here if you want. Okay, and the horizontal is 4. Horizontal is this way, right? You put a 4 right there if you want, showing me those, that you understand that. And then our graph is the branches here. And asymptotes, remember, are lines that your graph will not touch. So my green graph, this branch, will not touch the red or the blue dashed line. Okay? And then this one here, this branch, same thing. All right, some of you just did it real sloppily and you went across the 4 or across the 1. You're not supposed to touch the 1 or the 4. Does that make sense what I'm saying?
Do we have to put like actual points, or can you just draw freehand like that?
You can draw it freehand, but just make sure some of you just got real sloppy and just went, and you were crossing the 1s and the 4s, okay? Don't do that. All right, make sure you put it in the right spot, even though your calculator is doing the work. Doing it correctly, showing me you understand what's going on. Does that make sense what I'm saying? Okay? Just doing a quick flip of 2 lines there, 2 curves, show me you don't really understand what we mean about the asymptotes. Okay? Any questions on number 1? All right. Number 2, here's our function. This has a variable in the numerator. So finding our horizontal asymptote is a little bit different. Okay? So the vertical asymptote is still what makes that x give you a 0 in there. So if you're not sure, just set that denominator equal to 0 and solve it. What's the first step? That's 6. What's the second step? Divide by 3. What's 6 divided by 3? 2. So that's the vertical asymptote. All right? The domain then, which you didn't have to do, but would be what? X cannot. Right.
Yeah.
Right? Okay, so if I'm asking for a vertical asymptote or horizontal asymptote, it's x or y equals. And it's domain or range, it's x and y do not equal. But it's the same numbers. Okay? Now, for the horizontal asymptote, it's this coefficient divided by that one. So it's the top coefficient divided by the bottom coefficient. So my vertical asymptote, I'm sorry, I just did vertical, right? My horizontal asymptote is y equals 4/3. Okay? And then my domain, range, which you didn't have to do for this one, is y cannot equal 4/3. Now, when we graph this, all right, vertical asymptotes at 2, right? About there. 2 on the x, through the 2 on the x. And 4/3, if I had 1 here and 2 here, where's 4/3? 1 1/3, right?
Yeah.
So a little bit over the 1. Maybe I went a little too low. Looks more like 1 1/4, doesn't it? Sorry. But close enough. So just put, you can write 4/3 here if you want. And then we do our branches, which are in the same areas, top right and bottom left. Okay? Questions on number 2? Caitlin, that make better sense? Number 3, very similar to number 2. I guess just like it, really. Just different numbers. All right?
Do we have to
So-
do 2 of them on the test?
Yeah, it's going to be like this. It'll be 4 graphs and then 5 of the others. So you'll do the 4 graphs tomorrow and the 5 others on Wednesday. That's how I split it up. Okay? Yeah, just so you weren't rushed. You probably could get it all done tomorrow, but I don't want to have you guys be rushed, so we'll just make sure we have plenty of time. Okay? So there should be nobody not getting finished with either part. All right, so my vertical asymptote, remember, is the bottom. So that's x equals 2. And that's all we had to answer, right? And then my horizontal asymptote is y equals what? What's in front? A 1, so what's 2 divided by 1? 2. So they're both the same this time. Right? So then when I graph it, vertical at 2, horizontal at 2, And then my two branches, which are up in the top right again and the top or bottom left. When do they switch on us? Usually get negatives up top, right? Kind of flip, right? Okay. Making sense? Jordan, making sense?
Yeah.
Landry? Mason? Connor? Oh, Spencer's not here either, is he? I missed him. I was gonna say, right, Spencer? See if he was paying attention. Guess he's not, because he's not here, is he? All right. Number 4. We've got another one where the numerator is a whole number. So this is like the first one, right? So what's my domain? X is all real numbers except -2. And my range is all real numbers except 4. Right? Everyone okay with that?
Yeah.
What if it was -4 up there?
It wouldn't, it can't be.
What if I had a -4 up there? Then the y could not be -4. So whatever sign's in front of that number goes with it. What if there was no number there? What's the range?
Oh.
0. Yeah, y cannot equal 0, right? So if there was nothing here, remember that's when it's just a whole number in the numerator. Okay, no variable in the numerator. Okay? So again, a quick sketch. This time vertical is -2. And horizontal is 4 again up here. And my two branches are up left, bottom left, up right. Okay? So the graphing should be pretty easy, right?
Yeah.
So the first part, Sydney, everybody will get right tomorrow, right?
Yeah.
All right. For the second part, the simplifying and multiplying and dividing of rationals is we have to factor everything we can factor first before we start canceling factors, right? Okay? So what are the factors of -24 that add up to +2?
6 and
+6, -4. What do we call that denominator? It's got two terms, they're both perfect squares and a minus. Difference of squares. And when we factor those, we make two sets of parentheses and we take square roots, right? Square root of x squared, square root of 16, then what? Plus and a minus, one of each, right? Now, looking at the numerator and denominator, do we have any common factors?
X minus 4.
Right. The x minus 4s, right? So, my answer would be x plus 6 over x plus 4. And then there's another spot that you're supposed to tell me what x is not allowed to be, and you look at both factors. Yeah, just the bottom. Don't worry, top's okay to have 0, but the bottom. So -4 and a +4. So I would just put a ±4 like that. But if you just put it separate, a 4, comma, -4, that's okay. All right? Any questions?
No.
All right. Number 6, we have a multiplication problem. And we don't need to do any factoring here because there's no pluses or minuses. So we have our 6 x cubed y over 2x y squared times y over 3x. All right. So in this type of problem, when you have no pluses or minuses, it's already in factored form. So you can start canceling factors. The way I looked at it, I saw a 2 and a 3 in the bottom, which is 2 times 3 is what? 6. So I canceled the 2 times 3 with that 6. All right, so 2 times 3 is 6, cancels the 6. Some of you divided 2 into 8 and got a 4, and divided the 3 into 6 and got a 2, and then you went 2 times 4. And still got what in the top? What's in the, yeah. Either way you get 8, right? If you divide 3 into 6 and get a 2, and 2 into 8 and get a 4, you're still going to go 2 times 4 and get 8, right? Looking at the variables, I see 3 x's up top, 2 y's in the bottom, or 2 x's in the bottom. So where's the higher exponent, or the more x's? Top. All right. How many more x's up top? Just one. So there's 1 x up top. I look at the y's, I see 2 in the bottom and 2 in the top. So what happens to them? They cancel. So there's no y's left. So there's my answer, 8x. Now, what is x not allowed to be? 0. Right. If it's just an x with no plus or minus with it, it can't be 0. Because 3 times 0 is what? 0. Right. That one makes sense?
That one makes sense. I got that one.
All right?
If I get that wrong,
Yeah. Not good, right? All right, number 7. We see minuses, right? So I have to, wherever I see the minuses, I have to factor first. Okay? So here's our first numerator. All right, so I'm going to factor a 5x out of this, and I get x minus 3. It's got a GCF. That's always what we look for first in a factoring problem, right? The first denominator is a difference of squares, so we make 2 sets of parentheses, square root of x squared, square root of 25, one's plus, one's minus. This one, what are the factors of negative 30 that add up to negative 1? Positive 5, and a negative 6. And here there's no minus or plus, so do I factor it? No, it's basically already factored, right? It's 5 times that. All right? So I look for common factors. Well, right away, I'm going to get rid of those 2 5x's because they're common factors. I'm going to get rid of an x plus 5.
It's just a vicious one. Forgive it on the top.
All right? So there's nothing else. It's exactly the same top or bottom. So my answer is an x minus 3 and an x minus 6 up top. And an x minus 5 in the bottom. Now, we still have that. What makes that 0? negative 5. That one, positive 5.
Plus or minus 5.
Right, we could do that, right? And then what makes this 0? 5 times what is 0? 0. Questions? Jordan?
But it's still right if we have like x over 3 over x minus 5 times x minus 6 over 1.
Yeah, I guess that'd be okay, yeah. I just make it all one fraction. But yeah, you're right.
Because the problem is why that-
Any other questions? Sydney, you okay? Okay. All right, so just make sure we can factor. All right, number 8 is a division problem. So when I write division problems on my paper, which you guys don't have to on your paper, it's already written, right? I write it as a multiplication, but what's my other fraction look like? Gotta flip it, right? Are we remembering to flip that second fraction and multiply? In dividing fractions, you multiply by the reciprocal. Right? So the only thing I can factor is this first denominator. Everything else you can't factor. And what times what is positive 1 added is negative 1. Negative 2, sorry. Negative 1 and a negative 1, right? When I multiply them, I get positive 1. When I add them, I get negative 2. So looking at common factors, x minus 1, top and bottom, x plus 3, top and bottom. So everything's gone in the top. What number goes there? 1. Not a 0, it's a 1. Remember, when I divide something by itself, like 5 divided by 5, what's the answer? 1, right? Not a 0. So sometimes we get messed up when that happens. Remember, this will be 1 in the top, x minus 1 in the bottom. And x cannot equal 1 or negative 3. And if I'd use either of those numbers for x, I'd get an undefined issue dividing by 0. Okay? So the mistake we make sometimes is we get in a hurry because we're on a roll. We've done, a couple multiplication problems. So then we go into the division problem. We forget to flip that second fraction. So don't forget that. Last one, another division problem. Again, I'm going to rewrite it as a multiplication problem. So the x squared minus 7x plus 6 becomes the numerator, and the x squared minus 1 becomes the denominator. All right, so we're going to factor these. This is x plus 1 times x plus 1. This one's x minus 6 and x plus 3. This one's x minus 1 and x minus 6. And this is x plus 1 and x minus 1. Any questions on any of those four? How I got them? All of us by now should be able to factor those. Those aren't very difficult to factor, right? All my a values are 1. It's pretty easy, okay? So looking for common factors, x plus 1, there we go. Do I have another x plus 1 on the bottom? No. X minus 1, I do have another x minus 1 on the bottom. X minus 6, I do have 1 in the bottom as well. Okay? So I have an x plus 1 remaining in the top. And an x plus 3 in the bottom. And then x can't be 6, negative 3, and 1 or negative 1. So I'll just put plus or minus 1.
That's what I got.
So is this that difficult?
Nah.
No. You guys are going to do really well tomorrow and Wednesday. Right, mate?
What's your age?
Any questions? Okay.
Okay, well, tomorrow's the draft one.
Yeah, tomorrow will be just the graph one.
Right